Hello everyone. Today we are going to start with a new course regarding JEE Advanced, and I'm going to conduct the course of chemistry. So today this is our first video which includes the following topics, like we are going to discuss mole concept first, then atomic structure. So you guys don't have much time, so we are going to basically discuss about the very little things which might be very important in the session of 2020 JEE Advanced. So here I include few topics of mole concept. The first one I would like to discuss is equivalent mass. So when we are dealing with equivalent mass, then the very concept which is required, that is the definition. How do we define equivalent mass? That is E equals to molar mass of any substance divided by n factor. Now molar mass is easily known, as we can easily calculate that, but we need to know about the n factor of different species. Like if I'm talking about any acid base system, then the equivalent mass for the acid should be the basicity of that acid, and for the base it should be the acidity. Now if I'm talking about, for example, sulfuric acid, H2SO4, so as you know, the basicity of sulfuric acid is 2, so the n factor of sulfuric acid will be 2. And if I'm talking about, suppose, calcium hydroxide, so its acidity is 2, so its n factor should be 2. Now for a very fair discussion, if an equation is given like this, H3PO4 plus NaOH, which is producing NaH2PO4 plus H2O. Now in this reaction, as you can see, only one H plus of H3PO4 is being replaced by Na plus. So here, from here to here, if I am considering this reaction particularly, then the n factor should be 1. But as you can see, there are 3 ionizable protons in H3PO4, but in general you need to consider, according to the given equation, it should be considered as 1. Now if I am talking about the equivalent mass of any salt, so for example, we are given the salt Ca3PO4 whole 2. So this is the calcium phosphate. So you need to consider the total positive charge or the total negative charge produced by the cations and the anions, either of it. So if you analyze this salt, you will get 3 Ca2 plus and 2 PO4 3 minus. So the total positive charge or the total negative charge would be 6. So the n factor for this salt should be 6. Now if I'm talking about the very important thing, which is oxidant and reductants. Oxidants and reductants. What about the oxidants? The change during any chemical reaction, the change in oxidation number, the total change in oxidation number, or the total number of electron transferred during any redox reaction should be considered as the n factor for that particular oxidants or reductant. For example, if I am talking about this MnO4 minus to Mn2 plus, so here the oxidation number of manganese is plus 7 and here it is plus 2. So from plus 7 to plus 2, the conversion include the change in oxidation number of 5 units. So the n factor should be 5. Now the frequently asked problems regarding the strength of a solution. How do we calculate that? So strength of a solution. There are several strength concepts, that is the percentage concept, the mole fraction concept, as you all know about this mole fraction concept, the molarity concept, the normality concept, the molality concept. As we all know that the mole fraction is defined as the number of moles of any species I divided by total number of moles. Similarly, if I am talking about the molarity, I will get the mass of the solute times 1000 divided by molar mass of that solute into volume of the solution. Similarly, if I am talking about the normality, then mass taken of the solute times 1000 divided equivalent mass of that solute times volume of the solution. If I'm talking about molality, then we get mass of the solute taken times 1000 divided molar mass of that solute times mass of the solvent taken. So these are the few definitions that we need to keep in mind when we are going to solve any problem. So let us take a standard problem in order to realize this concept easily. So here we are asking that we have to make a match in between column 1 and column 2. So there are few mass of solute in a given amount of solution given in the column 1, and the corresponding concentration in molarity are given in column 2, though that is very easy. So let us see what we can do. In the first one, A, 4 gram of NaOH, so W2 is 4, so 4 gram of NaOH times 1000, we do that. Then we need to know the molar mass of NaOH. We need to keep that in mind, that is 40 times 500, so it will give you 0.2 molar. So obviously you get Q, so it is Q. The next B, it is asking, so 9.8 gram sulfuric acid, so 9.8 into 1000 divided by, you need to know the molar mass of sulfuric acid. Try to guess. Yes, it is 98 times the volume given 200. So if you solve it, you will get 0.5 molar. So this is P. The next one, C. What is asking in C? C, 3.65 times 1000 divided the molar mass of HCl. Take a guess. Yes, it is 36.5 into 100. So you get 1 molar. So yes, it is S. Now the last one, 12 gram of acetic acid. So 12 times 1000 divided. So the molar mass of acetic acid, you need to keep that in mind. Yes, it is 60 times 500, the volume given. So you will get 0.4 molar. So it is R. So a very basic thing that you need to keep in mind, the definitions of molarity, normality, molality to solve several problems. That will be easily done. Now moving to the next one, next topic, that is neutralization, which is frequently asked questions, comes from here, from the topic of neutralization. Now neutralization reactions, basically what does that mean? As all of you know by now, that you can perform any acid base reaction, any redox reaction. Now what do we do? For example, if we are talking about acid base reactions, we take a known concentration of an acid or base, which we call the standard solution. Then we try to find out the concentration of another solution by performing either acid base titration or by performing redox titration. Now if I am talking about acid base titration, so what is the main principle behind this? This is the principle of concept of equivalence. What does that say? It clearly says that number of equivalent of acid, for example, should be equals to the number of equivalent of base. And this concept, this law of equivalence, is applicable for any chemical reaction. Keep that in mind, students. It is applicable for any chemical reactions. Number of equivalent of A should be equals to number of equivalent of B, should be equals to number of equivalent of products as well. So all of them should have the same number of equivalents. Now from that concept we derive this V1 N1 is equals to V2 N2. Now what does that mean? Volume of any given concentration solution and the normal strength of that particular solution, and V2 the volume of another solution, and N2 the normality of another solution. Now putting this in a frame, we can easily find out if V and N are given, we can find out V2 if N2 is given, or vice versa. So it can be done very simpler ways. So as I was saying, let us take a look at this problem. It is saying that a compound H2X with molar weight of 80 grams, it is dissolved in a solvent which have the density of 0.4 gram per ml. Now they are saying that assume there is no change in volume upon dissolution. That means when H2X was dissolved in the solvent, there was actually no change in volume. That is they are saying. So now if the molarity of that solution is through 3.2, then they are asking to find out the molality of that solution. Now as we have discussed that molarity was equals to W2 into 1000 divided M2 into V, and molality was equals to mass of the solute times 1000 divided by molar mass of the solute times mass of the solvent taken. Now we can solve this in this way, that see, the molarity of the solution is 3.2. So it means that 1000 ml of the solution should contain 3.2 mole of H2X. Now 1000 ml of the solution, and the density of the solution is 0.4 gram per ml. So the mass of the solution would become 1000 times 0.4. This gram of solution would contain 3.2 mole. Now 3.2 mole of H2X will mean 3.2 times 80, because the molar weight of the H2X is 80. This gram of H2X. Now you have got this one which is W1 and this one which is W2. So now you have from the molality derivation, W2 you know, W1 you know, M2 you know, and 1000 obviously. So M is equals to W2 by M2, which clearly means the number of moles, which is 3.2 indeed. So 3.2 into 1000 divided, you will get W1 from here, which is 400. So you have to put the value over here. So by solving this you will get what? You will get 8. So the molality of the solution which was asked in the given question is found to be 8 molal. Now we were talking about the neutralization reactions, isn't it? So here is the problem about the neutralization process. See very carefully. It is asking that an aqueous solution of 6.3 gram of hydrated oxalic acid, the formula is given here, is made up to 250 ml. The 40 ml of 0.1 normal NaOH was required to completely neutralize 10 ml of the above prepared solution. What is the value of X? So what we can do, see, molar mass of oxalic acid, if you add up all these given datas, H2C2O4.XH2O, so you will find 90 plus 18X by taking in common of 18. So you will get this one. Yep. So equivalent weight, as we have learned in the very beginning of this session, that equivalent mass equals to molar mass, yes, divided by N factor. So the N factor for oxalic acid, since it is dibasic acid, should be 2. So the equivalent mass should be N 9 into X plus 5. So you have got the equivalent mass. So now you can easily find out the normality of this oxalic acid solution. So the mass given 6.3, yes, times 1000 divided 9 into X plus 5 into the volume of the solution prepared was 250. So we keep it like this. Okay. Now this is the normal strength, and from this solution we have taken 10 ml. We have taken 10 ml of this solution. So 10, as we know that V1N1 is equals to V2N2. Can you follow? So V1N1 equals to V2N2. So V1 is 10 ml times 6.3 into 1000 divided 9 by X plus 5 times 250. Now you need to know the V2 and N2. So V2C 40 ml of 0.1 normal NaOH. So 40 into 0.1. Now you solve this and you will find the value of X. You will find the value of X as X equals to 2. So the correct option goes option 4. Now another problem with this neutralization process we can observe in this question number 4, which is asking that see 5 ml 8 normal nitric acid, 4.8 ml 5 normal HCl and a certain volume of 17 molar H2SO4. They all are mixed and the combining volume is made up to 2 liter. So now first we can do what we can find out the normal concentration of the resulting solution. Now we need to solve this problem faster and accurately. What we can do, see 5 into 8 plus 4.8 into 5 plus, we don't know about the volume of sulfuric acid taken, so we are assuming it's V times. Now see, we are taking the concentrations in normality, but the concentration of sulfuric acid given in molarity, so you will just convert it into normality. So how can we do that? As you all know that normality is equals to n factor times molarity. So the n factor for sulfuric acid we just shown, yes, it is 2, so it will be 34. Now we have added the V1 N1 terms. Now the total volume of the solution is made 2 liter, so 2000, that is 2000 ml. So this is the resulting concentration when we mixed all the given acids. Now from this mixture they are taking out 30 ml. So this is the now the new concentration. So from here we are taking 30 ml, 30 into the concentration, that is V1 N1. Now V2N2, we need to find out the V2N2. Now this mixture, particularly this mixture, is neutralizing 42.9 ml of sodium carbonate solution, which is containing 1 gram of sodium carbonate, this one, in 100 ml of water. So it is equals to 42.9 times, let us do N2 for example. Now the value of N2 should be, what should be the value of N2 here? Now see, N for sodium carbonate is equals to the mass of sodium carbonate, which is 1 gram given, times 1000. Now the molar mass of sodium carbonate dot 10H2 you can easily find out, it will come out as 286. Now this times 100 ml given the volume of the resulting solution is given 100 ml. Now we equate this find value over here and we will try to solve and find out V. As you solve it, you will find the value of V is equals to 4. So this, the volume of sulfuric acid initially taken in ml, it is 4. So you have got your answer. So the next topic of the mole concept is regarding Stoichiometry, which is frequently asked questions come from this segment. Stoichiometry. In this segment, what do we do? Assume we have taken an hydrocarbon, okay, CXHY. Now we allow this hydrocarbon to undergo a combustion in presence of air, which means essentially in presence of oxygen. And as you all know that upon reacting with oxygen, it will certainly produce CO2 and H2O. So you can easily equate this balance this equation. This is x, this is y by 2, so this is x plus y divided by 4. Okay, so now what we do in Stoichiometry, we need to find out, sometimes we have to find out the formula of CXHY. So what do? We first cool down the reaction mixture and hence the water gets liquefied, so a volume contraction occurs. So the first volume contraction, obviously volume is, this is, for example, we have taken V volume of this hydrocarbon, so 1 plus x plus y by 4 minus x, this whole times V. So the V is the volume of hydrocarbon taken, and since the volume of H2O has been disappeared in the form of liquid, so what do we get over from here? V 1 plus y by 4. So a volume contraction, first volume contraction, if it is given and the volume of the initial hydrocarbon taken if given, then you can easily find out y. Now you might think, how do we find out the value of x? That is also easy. Now we allow this mixture to pass through potassium hydroxide solution. As you know, CO2 is acidic, it will be absorbed in potassium hydroxide solution. So a second volume contraction will take place, and that should be equals to x times v, because one volume of the given hydrocarbon is producing x volume of CO2. So v volume of hydrocarbon will produce vx volume of carbon dioxide, and that carbon dioxide has been disappeared when we allowed the mixture to pass through KOH solution. Now let us take a look, have a look in the regarding problem with this iodometry problem. What is it saying? A 20 ml mixture of CO, CH4 and helium gases exploded by an electric spark at room temperature with excess oxygen. So carbon monoxide given, methane given, and helium. So first we need to understand from this very concept that helium should not undergo any reaction with oxygen. So what we can do, just read the problem and convert it in the mathematical form. So volume of CO we have taken x, volume of CH4 we have taken y, and helium z. So we have assumed that, and this should be equals to 20. Let us assume this is equation 1. Now what is happening? The contraction in volume is found to be 13 ml. Mind that. So what do we do? CO plus O2 is equals to CO2. So it is half. Now the volume of CO was taken x. So this should be x by 2, and this should be. Now what about methane? So methane is also reacting with oxygen, CO2 plus 2H2O. Now this is y, so this should be 2y and this should be y. Now obviously this H2O should be transferred into the liquid form since the contraction of volume occurred. So what do we find here? See, the oxygen exhausted, O2 exhausted, x by 2 plus 2y, and CO2 produced, x plus y. Now moving to the next part of the problem, it is saying the contraction in volume is found to be 13 ml. So the first part of contraction of volume is found to be 13 ml. So the O2 exhausted, this is equals to 13. We get another equation 2. And a further contraction of 14 ml occurs when the residual gas is treated with KOH. So see, as we have learned that the second volume contraction is due to CO2, adsorption of CO2 by KOH. So CO2 produced is being absorbed by KOH, and the volume contraction is 14. We have got another equation. So we do have two equations of x and y. We can easily calculate. So we will find y is equals to 4 ml and x is equals to 10 ml. So what is they asking? What are they asking? The volume of CH4 in the original mixture. So the volume of CH4 we assumed y. So y is 4. So this is 4. So we have understood the iodometry. So as I was speaking about the redox systems, so we need to know about these for very particular things. For example, redox systems, you will have to keep this in mind. That is, for example, there are a few very important reactions. For example, if I am talking about MnO4 minus, in acid medium, MnO4 acidic medium, in the MnO4 minus is converted into Mn2 plus. So from plus 7 it is getting converted into plus 2. So the N factor over here is 5. For Cr2O7 2 minus, it is getting converted in acidic medium to Cr3 plus. So here the oxidation number of chromium is 6. So 3 unit change for each chromium. So the total change in oxidation number is 6. So the N factor is 6 over here. So you like these, you need to keep in mind very little changes. Also, if I'm talking about, for example, oxalate C2O4 2 minus in acidic medium, it is getting converted into CO2. So the oxidation number of carbon in oxalate, it is 3, and the oxidation number of carbon in CO2, it is 4. So the change in oxidation number for each carbon is 1 unit, and that for 2 carbons is 2 unit. So the N factor over here for oxalate is 2. Similarly, if I'm talking about ferrous oxalate, FeC2O4. So FeC2O4, see, if any oxidizing agent like potassium permanganate or potassium dichromate has been used, so it will definitely oxidize C2O4 2 minus to CO2. But at the same time, if ferrous is present in the solution, it will also oxidize that ferrous ion to ferric and C2O4 2 minus to CO2. So now what we can do, see, here the oxidation number is 2, here the oxidation number of iron is 3, here the oxidation number of carbon is 3, here the oxidation number of carbon is 4. So see what is happening, iron 2 to iron 3, a change in 1 unit. Carbon 3 to carbon 4, the total change is 2 unit. So the total change for ferrous oxalate should be 1 for iron, 2 for carbon. So total change 3. So the N factor for ferrous oxalate, N factor became 3 unit. So let us take a look now a problem regarding the concept of, again, the concept of strength or the basis of law of equivalence that we have learned in details perhaps. So in this problem particularly, in column 1 they are asking to find the value of x. They are asking to find the value of x in different ways, and the corresponding value of x is given in column 2. So what are they asking for? Let us have a look in the first problem. 5 mole of an equimolar mixture of ferric oxalate and ferrous oxalate will require x mole of KMnO4 for complete oxidation in acidic medium. Now 5 mole of equimolar mixture means 2.5 mole each. Now as we have all know, the number of equivalent is equals to N factor times number of moles. This is known, since normality is equals to N factor times molarity. So number of equivalents equals to number N factor into number of moles. So first of all, what we have to do, we need to find out the N factor for ferric oxalate, ferrous oxalate and KMnO4. So it is very easy. See, ferrous oxalate, FeC2O4, it will produce Fe3 plus CO2, and we have just seen that N factor for this change is 3. If I am talking about ferric oxalate, Fe2C2O4 whole thrice. So obviously ferric iron is in its maximum oxidation number, so it will not undergo any oxidation. Only oxalate will get oxidized to CO2. Now see, the oxidation number of carbon in oxalate was 3 unit plus 3, and that in carbon dioxide is 4 unit plus 4. So total change for carbon, each carbon is getting changed with a value of 1 unit, but there are 2 into 3, 6 carbon, there are 6 carbon atoms in ferric oxalate. So total change will be 6. N factor should be 6 for ferric oxalate, and that for KMnO4, it will produce Mn2 plus that we have already learned. So for this system KMnO4, the N factor should be 5. Now the thing is very simple. The number of equivalent of ferric oxalate and the number of equivalent of ferrous oxalate, total of them should be equals to the number of equivalent of KMnO4. Now KMnO4 is requiring x mole. So x times, so the number of equivalents of KMnO4 should be what? X times, yes, 5 is equals to the number of equivalents of ferrous oxalate and number of equivalent of ferric oxalate. So number of equivalent of ferrous oxalate should be 2.5 times what? 3, and that of ferric oxalate 2.5 times 6. Yes or no? So if you solve this, you will find the value of x as 4.5. Moving to the next one, see, in the next one they are asking 5 mole of equimolar mixture of ferric oxalate and ferrous oxalate requires X mole of potassium dichromate. So similarly, 5 mole each means 2.5 into the N factor for ferrous oxalate 3, N factor of ferric oxalate 6. So 2.5 into 3 plus 2.5 into 6. So this should be equals to X into the N factor of potassium dichromate that we have already seen, that is 6. So if you find out the value of X, you will get the value of X to be 3.75 mole. So in the previous one, X is equals to 4.5 mole. So A is Q and B 3.75, that is B R. In the next one, they are asking 5 mole of equimolar mixture of CuS and Cu2S will require X mole of KMnO4. So now what is happening, see, the CuS, it is getting converted, it is plus 2 in the maximum oxidation state of copper, and sulfur is minus 2. In acidic medium, sulfur will form S, colloidal sulfur, which is 0. So the N factor becomes N equals to 2. And Cu2S, here the oxidation number of copper is plus 1 and oxidation number of sulfur is minus 2. It is getting converted into Cu2 plus S. So the total change in oxidation number for copper is 2 unit and that of sulfur is 2 unit. So the N factor for Cu2S becomes N equals to 4 unit. So similarly, what we can do, equimolar mixture of 5 mole of equimolar mixture of CuS and Cu2S. So for CuS and Cu2S system, we will get 2.5 times 2 plus 2.5 times 4 is equals to X times 5. If you solve this, you will get X is equals to 3 moles. So for C, the option correct goes with S. Now the last one, in this one, 4 mole of equimolar mixture of KMnO4 and K2Cr27 requires X mole of H2O2 in acidic medium. So for D, 2 times 5 plus 2 times 6, 5 for KMnO4, 6 for K2Cr27 is equals to X, the N factor of H2O2, which is in acidic medium 2. So if you solve this, you will get X is equals to 11. So the correct option with D goes with P. In this problem, they are asking to measure the quantity of MnCl2 dissolved in an aqueous solution, which is completely converted to KMnO4 using the reaction given. The equation is not balanced. Now a few drops of concentrated HCl were added to this solution, which means this solution, and gently warmed. Further, oxalic acid, the weight to 25 milligram, was dissolved in portions till the color of permanganate iron disappeared. Now they are asking that the initial MnCl2 which was taken, they are asking to find out that. Now what we are doing, see, MnCl2 plus, I'm doing like this, S2O8 2 minus plus H2O, this is equals to MnO4 minus plus SO4 2 minus plus HCl. Now see, here the oxidation number of manganese is plus 2 and here plus 7. So the total change in oxidation number 5 units. Now in S2O8 2 minus, we know that there is one peroxo bond. So the oxidation number of oxygen over here is minus 1. And that in sulfate it is minus 2. So from here to here, the total change in oxidation number for sulfur is 2. 1 for each sulfur, that is there are 2 sulfurs, so total change is of 2 unit. Now in the next process, when oxalic acid was added, KMnO4 plus oxalic acid, it is producing Mn2 plus and CO2. Now number of moles of oxalic acid is equals to 225, which is given, divided by the molar mass of oxalic acid. As you all know, that is 90 times, it was given in milligrams, so 10 to the power minus 3. And as you can see from this equation, the number of moles of per Mn2 plus and number of moles of MnO4 minus should be equal. So we can say that N of MnO4 minus should be equals to N of MnCl2. So now what we are doing, we are equating the number of equivalents for MnCl2 and that of oxalic acid. How are we doing that? We are doing that 225 divided by 90 into 10 to the power minus 3. So this is the number of moles of oxalic acid into the N factor will give you the number of equivalents of oxalic acid, that is the 2 for oxalic acid N factor is equals to W, that is the mass of MnCl2 mass which is asked, divided by the molar mass of MnCl2. For manganese, see, it is given 55 and Cl2 35.5. So total 55 plus 71 times the N factor for MnCl2, which is 5, and milligram in milligram units they are asking, so into 10 to the power minus 3. So if you solve this, you will get the value of W, that is the mass of MnCl2, equals to 126 gram, 126 milligram. Moving to the next topic, which is atomic structure. Now in atomic structure, we will discuss the atomic structure in the problem approach. Atomic structure. First, we will see the Bohr's model. The Bohr's model, where we deal with the radius r. As we know, r is proportional to n square divided by z. Then we will talking about velocity of an electron at any given orbit, Vn proportional to z by n. Then we will be talking about the number of revolution per second. Number of revolution of an electron per second is equals to 6.56 into 10 to the power 15 z square divided by n cube. And in this part, we all know the z is the atomic number and n is the principal quantum number. In the next term, we will see the potential energy is to kinetic energy is to the total energy of the electron at any particular orbit, which is minus 2 is to 1 is to minus 1. So these are few informations that we need to know when we are dealing with Bohr's model. So let us have a look at a given problem. In this part, they are asking to match column 1 with column 2. Now see what is given in column 1: angular momentum, orbital angular momentum, wavelength of matter, quantized wave value, orbital angular momentum. So what we can do, see, as we know that angular momentum according to Bohr's model, is equals to mvr is equals to nh by 2 pi, So first clue that A has a match with Q and R. Next, when we are talking about B, which is stating orbital angular momentum. So that we come to know from Sommerfeld theory, that orbital angular momentum that is equals to root under L into L plus 1 h by 2 pi, where L is the azimuthal quantum number or subsidiary quantum number proposed by Sommerfeld. So B have a match with option P in column 2. In C, wavelength of matter. So matter wave, from de Broglie concept, we have the knowledge of matter wave. So from de Broglie, what do we know? That lambda is equals to h divided by mv. So mv is the momentum, the linear momentum of any particle, of any object, which is designated by P. So C has a match with option S in column 2. And in the last one, quantized wave value. As we know that the angular momentum of any electron at any particular orbit is quantized. That is, it is a simple multiple proportion, integral multiple proportion of a given value, which is h by 2 pi. And the angular momentum of electrons in the successive orbits will be an integral multiple of h by 2 pi. So quantized wave value should be mvr is equals to nh by 2 pi. So again, D has a match with R in column 2. Moving to the next topic, we are seeing the atomic spectra. Now in atomic spectra, as you all know, that there are several series observed, like Lyman series, Balmer series, Paschen series, Brackett series, Pfund series, and Humphrey. And we know that Balmer comes in the visible node zone, where Lyman lies in the UV zone, Paschen, Brackett and Pfund lies in the IR zone, and Humphrey lies in the far IR. IR means infrared. So these are the series of lines that are observed when hydrogen spectrum is analyzed. Now, as you know, the Rydberg equation, which can easily explain, Rydberg equation, which is used to explain the origin of these lines, Rydberg equation, which is used to explain the origin of these lines, 1 by lambda, which is known as the wave number nu bar, is equals to Rydberg constant RH times Z square, which is the atomic number, 1 by N1 square minus 1 by N2 square. Now keep this in mind. Sometimes students, you get confused then where to put N1 and where to put N2. Then don't get confused. You should take the mod value, okay, so that you will not be facing any kind of problem of having any minus answer or plus answer. You will just take the mod value. You will not have to think about putting the N1 or N2 first or second. Now when an electron is undergoing any transition, electronic transition, when an electron going any transition, it will produce lines, right? It will produce lines. So the total number of lines during any electronic transition is equals to N2 minus N1 multiplied N2 minus N1 plus 1 divided by 2, whereas N2 is the final principal quantum shell and N1 is the initial principal quantum shell from where the electron went the electronic transition. And for a given series, number of lines in a given series is equals to N2 minus N1. This is the total number of lines in a given series. So if I am talking about Lyman series, suppose I am talking about Lyman series. So what do we do? If I am talking about Lyman series, we do that we put the value of N1 1 and we get N2 value 2, 3, 4, 5, 6, 7 and so on. When we are talking about Balmer series, we put the value of N1 equals to 2 and N2 is equals to 3, 4, 5, 6, 7 onwards. So these are the patterns that we know we should do. Now if I am talking about Lyman, the electron has gone any transition from N1 equals to 1 to N2 equals to 4. So total number of N1 is equals to 1 to N2 is equals to 4. So the total number of lines in Lyman series for this electronic transition should be 4 minus 1 is equals to 3. Total number of lines for this transition. Now let us have a look to a problem. Now what is it asking? Which statement is or are correct about hydrogen spectrum? Is or are correct, which means there are more than one type of answers. So let us take a look. Energy of second orbit is different for 1h1, 1h2 and 1h3, that is protium, deuterium and tritium. So now see, the number of protons in all of these species and number of outermost electrons in all of these species are same, only differing in the number of neutrons. Now the second energy orbit. Now the energy of any orbit depends on the number of protons in the nucleus and the number of electrons in the outermost shell. That is same for all these atoms, 1h1, 1h2 or 1h3. So it is obviously not correct that energy of second orbit is different. This is not correct. Visible spectrum can be obtained in Lyman series and Balmer series. Now as we have just seen that Balmer series lies in the visible zone and Lyman series lies in the UV zone, but they are asking that visible spectrum can be obtained in Lyman series as well as in Balmer series. This is also not correct. Now infrared spectrum is obtained in Paschen, Brackett and Pfund series, that we have seen that infrared, Paschen, Brackett and Pfund. So This is also correct option. Total number of emission lines obtained in Balmer series is n minus 2. So see, for Balmer series n1 was 2 and n2 can be anything above 2. So where n is the principal quantum number and n value must be greater than 2. So it is also correct. Moving to the next topic, which is photoelectric effect. Now students, we are dealing with some specific things in photoelectric effect, like according to Einstein's equation, which is saying that h nu is equals to h nu 0 plus kinetic energy of the electron. What is nu? Nu is the energy of the photon that has been emitted on the surface of any particular metal, for example rubidium, potassium, etc. Nu 0 is the threshold frequency, and h nu 0, as we know, the work function, and Ke, that is the kinetic energy of the electrons emitted. The very few things that we need to know, that if we plot kinetic energy of the electrons emitted as a function of nu, so from this equation 1 we can easily observe that the graph should be like this. And you need to know that the kinetic energy of the electron emitted is independent of the intensity of light, incident light. So the graph should be like this. Now see, if you have to find out the kinetic energy of the electrons emitted, Ke is equals to h nu is equals to hc by lambda. Sometimes they might ask you that to find out the lambda for a given kinetic energy or vice versa. So now what you have to keep this in mind, that kinetic energy, which is essentially given in the unit of electron volt, is equals to 1240 divided by lambda, the lambda given in the nanometer unit. So keep this in mind when you are dealing with any problems of photoelectric effect. So now let us have a look at a problem regarding the photoelectric effect. Now what is asking, the photoelectric behavior of potassium, lithium, magnesium, silver metals is shown in the plot below. So here the kinetic energy of the photoelectrons given, and here the energy of the photons given. So just we have seen kinetic energy with the frequency of the photons. So the photon energy and kinetic energy. So we are getting these kind of lines. So if the light of wavelength 400 nanometer is incident on each of these metals, which of them will emit photoelectrons? Now see, we need to know the energy that is provided on the metal surface, which is equals to hc by lambda, but we are trying to keep this in mind in the form of 1240 divided by lambda, which is in nanometer unit, so that we can easily calculate the energy of the incident photons from this equation, which is 1240 divided by lambda given 400. So it is roughly equals to 3.1 electron volt. Now for those which have the threshold frequency less than 3.1 electron volt, for those metals which have the threshold frequency less than 3.1 volt should undergo the photoelectrons emission process. Now from this graph you can see the cut point over here should correspond to nu 0, which is the threshold frequency. Now the threshold frequency of potassium and lithium, as you can see from the given graph, is less than 3, and that of magnesium and silver greater than 3. So magnesium and silver will definitely not undergo any kind of photoejection. Only potassium and lithium should undergo any photoelectron emission process. So the correct option goes with option 2, that is potassium and lithium. Now the next topic goes with de Broglie equation. De Broglie. Here we are dealing with the matter wave, where de Broglie equation states lambda equals to h by mv. Now if you solve this, you will get lambda equals to h by root under 2 me, where e is the kinetic energy of the microscopic particle like photons, electrons, alpha, protons, neutrons, etc., etc. So from here we can easily observe that lambda proportional to 1 divided root under m times e. So this is the basics of the de Broglie equation, and we are now going to deal with this equation in a given problem. So see, what are they asking? E alpha, EP represent the kinetic energy of an electron alpha particle and a proton respectively. Now they all are moving with the same de Broglie wavelength. Then they are asking to relate EE, E alpha and EP. So first of all, that we have just seen lambda proportional to 1 by root ME. We note down that here, lambda proportional to root under ME. So the lambda of all these are same. They have stated that. So from here we can say that E inversely proportional to M, since lambda are same for all these particles. So EE is to E alpha is to EP is equals to 1 by M E is to 1 by M alpha is to 1 by MP. Now the mass of electron is least and the mass of alpha is the maximum, because one alpha particle means this helium nucleus. So mass of alpha has the maximum value and mass of electron has the minimum value. So this have the maximum value because ME is minimum. So E is maximum and E alpha is minimum and EP lies in between. So the correct option is option 4. Moving to the next topic, that is the quantum model. Let us have a look at this problem first. Again, they are asking to make a match in between column 1 and column 2. In the column 1, few graphs and information related wave functions are given, and in column 2, they are asking to relate those wave values or those graphs related to the wave function with the corresponding orbitals. So let us have a look at the first one, option A. Now see, as you know that number of radial nodes is equals to n minus L minus 1, where n is the principal quantum number, L is the azimuthal quantum number, and number of angular nodes is equals to L. So, and the number of total nodes is equals to n minus 1. Node means, what is node? There is a region at which the probability of finding the electron from a certain distance from the nucleus is minimum, rather 0. The probability of finding the electron from a certain distance from the nucleus is 0. That is called the node. Now in column 1, the first graph, at the first graph, see at this point, and at this point, the number of nodes total 3, because at these points the value of psi, which is the wave function, the value of wave function is 0. So these represents the radial nodes, the nodes. So the number of nodes for this given graph, the number of nodes are 3. Now if we break down for 4s orbital, number of nodes 4 minus 0 minus 1, n minus L minus 1 is equals to 3. So 4s orbital also have 3 radial nodes. So A have a match with P. We have got our first match. Now moving to the next one, B. See in B also they are plotting the radial probability density. The radial probability density versus the distance from the nucleus. Here also first, second, third, 3 nodes are present. So obviously B will have certainly a match with P, 4s. And also if I'm talking about 5p orbital, then see 5 minus 1 minus 1, n minus L minus 1. So again we do have 3. So 5p orbital should also have 3 radial nodes. So this graph may be of 4s or 5p. So B has a match with Q as well. Moving to the next one, angular wave function is independent of theta and phi. As you know that the s orbitals are spherically symmetrical. They don't have any kind of directional property. So theta and phi basically define the directional property of any orbital. Since s orbitals do not have such, this particular statement should be true for 4s and 3s orbital. That is, C has a match with P and R. Moving to the last one, at least one angular node is present. Now angular node is equals to L. So L value should be at least 1. L value should be at least 1. Now if I am talking about 4s, S, for S L value 0. 3s L value 0. So not for not P, not R. Any 5p orbital, for 5p L value is equals to 1. So at least one angular node is present. For 6d L equals to 2. That is, at least 2 angular nodes will be there. So which means at least one angular node is present. That is true for 5p as well as for 6d orbital. So it has a match with Q and S. Moving to the last topic of this segment, that is the quantum number concept. Now see, spin angular momentum of an electron has no analog in classical mechanics. As you know, the spin quantum number ms have either plus half or minus half values. It has no classical analog in classical mechanics. However, it turns out that the treatment of spin angular momentum is closely analogous to the treatment of orbital angular momentum. As earlier we have discussed, the orbital angular momentum is equals to root under L into L plus 1 h by 2 pi, which is also given over here. Spin angular momentum, this one, orbital angular momentum, this one. Now what are they asking on the basis of this given passage? That the total spin of Mn2 plus ion will be. Now if you write down the electronic configuration for manganese having the atomic number 25, you will see the electronic configuration of manganese is argon kernel 4s2 3d5. So for Mn2 plus, the outermost electrons will be lost first. That is, from the 4s orbitals electron will be lost. Argon, this is 3d, 1 2 3 4 5, and 4s 0. So there are total 5 unpaired electrons, 5 unpaired electrons in Mn2 plus ion. If each have the spin value of plus half, so the total spin should be 5 times half, that is 5 by 2. So the correct option goes with the option 3. And the next question regarding this, they are asking that which of the following electronic configuration have zero spin multiplicity. Now what is spin multiplicity? Spin multiplicity is equals to 2s plus 1. Now what is S? S is equals to total spin. Zero spin multiplicity, right? So for zero spin multiplicity, for according to this given equation, as you can see, generally there cannot be any kind of zero spin multiplicity. Okay, either the S value may be 0, so the spin multiplicity is 1, 2 or 3 or something like that. But see, for this one the total spin are 0. For this one or this one, for this one the total spin 3 by 2, again for this 3 by 2. But for this one, see, it goes against the Horn's multiplicity principle. That is, the orbital filling up electrons, the first electron have a opposite spin as compared to the last two electrons, which goes against the Horn's multiplicity law. So obviously for this kind of system we will have no spin multiplicity. So spin multiplicity for this, spin multiplicity is not applicable. So the correct option is option 2. So now we have finished our first topic regarding mole plus atomic structure. Hope you have understood what do we have to learn for JEE Advanced 2020. So keep studying hard and hope for the best. Thank you.